Well, thanks everyone for coming. It's I guess time, and a few people might trickle in a little late. The great thing about Puzzlers is that it doesn't matter if you come a little late, like Adrian. So this is fun, right? I hope everybody's had a great Scala days. I've certainly had a great Scala days. It's been a lot of fun, and now we're coming to the end. We've hopefully learned a whole lot, and now it's time to relax a little bit, have fun. Nobody gets fired for getting a puzzle wrong. That's what we tell you. But secretly, of course, all your results are videoed and sent back to your bosses to evaluate your performance. Anyway, so those of you who know a bit about Scala Puzzlers, I did this last year. I have lots of newfound sympathy and respect for anybody who's ever written a book, because I've just been through that. And one of my colleagues said I spent a bit too much time promoting it, so I'll obviously try and keep the promotion down this time, so I'll be doing the entire talk behind this book. No, but if you're interested, Artemir's around, we're around afterwards. So those of you who know a bit about Scala Puzzlers know that there's normally two of us, me and Nerman. Unfortunately, this time Nerman couldn't make it. He's very busy teaching a course at Harvard, and we should all pity him, because as we know in New England, the weather's pretty bad right now, so poor Nerman, who's been busy working very, very hard, and he can't be with us this time, but hopefully, of course, he'll be with us next time as well. So I'll skip the popcorn quiz. So this is who knows the format of Puzzlers or Java Puzzlers? Just quick, who's seen a Puzzlers talk before? Okay, so for those of you have a bit more time to either take a snooze or don't eat your popcorn, because you don't eat in here. For the others, just a very, very brief introduction as to how this format works. What is a puzzler? Well, a puzzler is an intentional language feature, not in the sense that the language intends to confuse you, but that it works as designed. So it's not something against which a compiler bug is currently open or something like that, where there is consensus that this is clearly broken. May in future become something that we decide Scala shouldn't be doing anymore, but as of now, this is the way the language is really designed to work. It's also supposed to be legitimate in the sense that the behavior that you see is not just confusing because you don't understand Scala. And if you look at this sentence of 8 different exclamation marks and can't figure out which one is which overloaded operator because you don't know the language, that's really not the point of a puzzler. The point in the ideal puzzler, in my view, is a one-line sentence that everybody thinks they understand and that behaves differently from the way we think it does. So yeah, this is not about, oh my god, I've never seen this operator before, who declared like a Unicode smiley face to mean contains or whatever. It's really supposed to be simple, legitimate, understandable Scala, and it's also not supposed to be surprising because you just haven't learned Scala enough yet. It's not like the day one, I have no idea what a case class is, so its behavior seems strange because I'm not expecting it to do stuff. Obviously, whatever reasonably skilled happens to mean in the Scala world. So that's giving you a kind of idea of what we're going to be looking at in a second. So we have a bunch of these. I don't know how many we're going to get through in the time. If we get through all of them, that's even better. One thing that's maybe going to be a little different this time from previous times is I'm going to spend a bit more time talking about what we've learned about each particular puzzler, especially also as a result of trying to research them properly for the book, and what kind of advice we can give or we've come up with to try to help you avoid these kind of things in the future. I just ran all these against 2.11.2 and in fact also against 2.11.6. So the other thing is this: they don't require any libraries. They don't require to be run in this particular IDE. These are just the snippets of code that you're going to see. You should interpret them as if you would just open a brand new REPL and you paste them in there, and that's what we're going to be talking about. Now I'll tell you where I've removed some things just for clarity, like imports or those kind of things, but that's the context that we're talking about here. Of course, you're more than welcome to get all of them right by just running them in the REPL, but then you're going to be depriving yourself of the fun. It's like watching the end of a horror movie before you watch the movie. That was a weird comparison because clearly this is not a horror movie. Let's cut that out as an edit. That never happened. So yeah, of course you're more than welcome to do this, but in your own interests, I would suggest that you don't. Having said that, that was our short 5-minute snooze break. Well, it wasn't even 5 minutes. So let's go. Here's the first one. And again, I'm going to do this for all of them. I'm not going to try and, this is not meant to be an exercise to understand code. I will try and explain roughly what the intention of the code is supposed to be, and then we're going to show a couple of candidate answers. Then I'm going to dance around here in this beautiful place of sunshine for like 30 seconds or 2 minutes or whatever, and then we're going to have a vote, and then we're going to explain the answer. So what's happening here is we have an object, and within that object we have two other objects, each one of which has a value, and the statement that initializes that value refers to the other one. So you can see here that x.value refers to y.value, and y.value refers to x.value. And then we print, based on a random condition, either xy.x.value or xy.y.value. Here are your choices. Prints 1, prints 2, prints either 1 or 2, randomly, throws a runtime exception. No, we'll do have a little show of hands in a second, so you can think about it. Now I should have studied like 13 Hungarian folk dances or something, because I could now do something. Now I just have to stand here and watch. Yeah, but I only know 2, so they'll just be repeats all over again. So a few seconds again, so it's a random. You print the one, print the other. Here are your choices. What do you see? Anybody want a lot more time? Kind of have an idea? Tick tock, tick tock. Still thinking? Okay, we'll give you a bit more time. Ooh. And to be clear, irrespective of the answer of this, of course, the point here that we're going to talk about in a second in a bit more detail is recursive, mutually referential initialization. That's really the background here. What do we have actually? 5 something. Lots of whispering, so people say, you can work in teams, that's okay. All right. Time here. Wow, so the noise level for 30 seconds it was totally quiet, and then the whole debate starts happening. People like running through this in their head. Let's give it 20 more seconds. I need one of those foghorns, like. Okay, guys. Who thinks it's A? Who thinks it's A? A couple of hands. Who thinks it's B? Or who thinks it's C? About the same as B. Who thinks it's D? Oh, you see, there's already discord. That's the whole Scala community fighting again, or no? Right. The answer is B. So those of you who got B, very good. And it's actually kind of unusual. Well, I mean, it's unusual in the sense that this is a special case. So I'll explain how and why it's B in a second. But more importantly, I'll also talk about what happens if you're not using objects. But as a short aside, all the code, so you don't just take it from me, we're going to look at a very cool thing that you may or may not have heard of, Marconi's REPL-isent, and I have to go back through the history because I practiced this earlier, of course. So this is a in-REPL slide deck thing, very, very cool, very nice. Now I have to go through most of the history again, and this is where we're going to go through the code samples. So let's have a look. F is to start the presentation. So here's Init You, that's what you just saw, there's the code, and now we can hit the magic R button, which will run that code for us, and you can see it hits 2. And I'm not sure, I probably can go back and run it again. No slide from me. Oh no. And it hits 2 again. And I guess if we run it again, it'll be 2 again, and again, and again. And you're doing the 2 to the power of n in your head now, and you can see that the chances of this, it's pretty small. Okay. So Why is this 2? Well, okay, let's first of all talk about what happens. Whichever one you pick, it'll go down that branch and it will try and initialize. So let's say it's greater than 0.5, and then it'll try and initialize xy.y.value. So it goes into value, and then it realizes it has to get x.value. So it starts initializing x.value, which means it has to initialize x. And then x starts to initialize y. Now, y is an object class. And in the JVM, you can't initialize, so you're an object again. So once an object is in its initialization phase, you can't, it's not reentrant. So at this point, it says, okay, well, we're not going to restart the initialization for y. We're just going to have to take the value of y as it exists at this point. Y hasn't been initialized yet. So the default for y.value in this case is 0, which means that x.value becomes 1 because it's 0 plus 1. And then y can finally retrieve x.value, which gives you 1. 1 plus 1 gives you 2. So the one that you pick, whichever one it is always 2, and the other one is always 1. And the interesting thing about this construction is that you're very lucky that the JVM helps you from being reentrant here, because if you rewrite this in any way, in fact the Scala spec says you should think of objects almost as if they were a little bit like lazy, this initialization as if it were like lazy vals. If you try to rewrite the same thing using lazy vals, you get an endless loop. And if you try, in fact any other thing, if you turn the objects into classes, you will also get an endless loop. The only thing that saves you here is the static initializer, the JVM at the JVM level of the spec prevents classes from being initialized recursively. So there's a very kind of interesting and weird thing here. Long story short, don't do this. Right? Recursive initialization is almost never necessary. Of course, in a trivial example like this, it's obvious. The problem happens in larger applications where you're not necessarily aware of the fact that you have a cycle. But if you have cycles, if you can't break a cycle, you need to be really, really clear that you understand its initialization behavior, because otherwise you can get all kinds of weird stuff happening. That's a good start. All right, next. Yes, sure. Oops. Yes, sorry. Yes, thank you, Adrian. It's always good to have somebody who understands 2 trillion times. Well, it doesn't matter, but at least you can explain it, right? I mean, so it's always good to have 10 trillion times the accumulated Scala knowledge in the audience compared to me, so they can add these kind of things. All right, here's the next one. So what's happening here? So we have a case class being defined here with it's one of those squeaky toys. Oh, it's a hand up. Of course. Yes.
So is this, you said it was safe because the JVM, is this
yes.
not part of the Scala spec, right? So when you run this on Scala JS, you wouldn't necessarily...
Huh?
I think it's like a class to static initializers.
Yeah, so it really depends on how Scala JS interprets static initializers and whatever guarantees would exist there. Yeah. Adrian, what do you say? Perfect. Why did you stand here? No.
I think it's going to eventually do the same thing, where it's going to come back down to whatever the default value is for something, which I guess on JavaScript would be undefined. So what happens when you do plus 1 plus 1?
Oh, JavaScript, so isn't it like an array? Yeah. There's an entire presentation about this in JavaScript, so let's not go there right now. Scala JS, I think I need to register Scala JS Puzzlers. There's an entire subcategory. Okay, I'm sorry, does that answer your question? I mean, so okay, the next one. We have a case class. It's a squeaky toy, and it has a squeeze message, and the default value for this squeeze message is this toString, and it overrides its own toString to print out this squeeze message. Now, it's a default, so you don't need to specify the squeeze message, don't forget. But what we then do is we compare 2 toys, one created using the factory, and one created explicitly with the squeeze message and without the squeeze message. And now your options, this fails to compile, it's not valid. Prints true, prints false. It prints true and false. That's a mistake. That's obviously meant to be prints prints true and prints true. Oops, good thing it's a PowerPoint deck. So let's do that. Tur, it's true and tur, and the first statement prints true, and the second throws a runtime exception. What's not in here? Damn. Yeah, I know. I just need a TikTok, and some. Maybe I can get a. I can throw individual pieces of popcorn to count, like 1 a second. Not a good idea. Yeah. No. That's runtime. Well, I guess it would have been a runtime exception because it blows up with a Stack Overflow. No. Oh, you can actually deadlock. Yeah. Same. Yeah. Thank goodness this isn't a library. So let's give it like 50 more seconds. Well, we've got a lot of talking to do. Okay. Huh? Okay, sorry guys, we have so many to go through, it's going to be much more fun if we can go through more of them. Who thinks it's A? Fails to compile. Who thinks it's B? Prints true, false. Who thinks it's C? Prints true, true. That's the problem with puzzles, right? The obvious answer, of course, we know. It's who thinks it's D? Runtime exception. All right, again, good mix. So the answer is B. Prints true, false. So, let's show you. Don't believe it? I know, weird, huh? Let's have a look. Next. So next slide. Print toy. Now, right, run. True, false. Define class toy. So what is happening here? What on earth is happening here? Well, let's do something here. Let's go val t equals toy. Yeah, let's look. Yeah, somebody knows the answer. And then let's go println t.toString. What's this? Oh, that's toy. That's okay. Now let's go val t2 equals new toy. Isn't this cool? This is so cool. Thanks, Marconi. Ooh. Right. What on earth is going on here? Well, what's happening here is that the this is kind of leaky. So, I mean, I first thought that this couldn't compile because what's the this actually even mean at this level? What on earth is it referring to? Is it referring to toy itself? Well, it can't really, although ironically enough in the case of the copy method, there's some incredible class constructor magic that makes this work. The point is that the this actually refers to whatever is invoking, or where in which, yes, Miles? Yeah. 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 You mean if you put this in an object, if you go object or just in a package? Okay. Yeah. Okay. Then, well, we can certainly try it. Let's do that afterwards for sure. Yeah. Thank you. We have somebody who's got a laptop. So excellent. So I'm saved by the fact that this happens in the REPL. Very nice. So okay, so we'll explain this in the REPL. Yes, obviously you need a reference to an enclosing this. That's true. If you're in a package, there is no enclosing this, so this blows up. Here it doesn't. And the weird thing is, of course, that when you're calling new, the this is whatever enclosing object happens to be, which in the REPL case is some weird script object thing you've never seen generated by the REPL. And in the case of toy, it's somewhere in the apply method of toy. It's calling new toy. So the enclosing object that is invoking the constructor is actually the object, companion object. And that's why when we went and had a look at this here, this is why this thing happens here, because toy is the companion object. So that's the this at the moment that constructor is invoked. Weirdness. And so this is debatable as to whether this is really intentional or not. It's not covered, I think, by the spec exactly. But this, okay, all right. So it's not even a puzzler. So let's move on. Let's pretend it never happened. Next one. Yeah, there's a long ticket about this that talks about a lot of the different cases. All right, so trial and error. So again, this is not the indenting makes it look harder than it is, but it's not that bad. So we have a try. You give it two numbers and you try and divide them and then take the square root. So you try and divide n divided by d, and then you say, well, if the value, if the result of that is smaller 0, then you're going to have to fail because you can't take a square root of a negative number. Otherwise, you say, okay, great, success. We have a square root of a negative number. So we've mapped from one try to another try, and then we map to, okay, let's pull it out if it's successful, obviously, and then we'll print the square root. N divided by d equals the value. And then we try that once by trying to divide 18 divided by 2, and then taking the square root of that, and then by the 18 divided by minus 2, and taking the square root of that. So now your choices. So I'm sorry, again, the indenting is a bit strange here, but I've tried to separate this. There's two lines always being printed. So the first one is that it prints, well, success, because that works. And then it says, well, no, you can't do the success of an exception. Or you get success and then failure with a particular exception. Or you get some weird thing, or some other weird thing. I'll just let you look at this for a second, and we'll go back to the code, because you have to, now you're seeing what the options are, then you can then go back. And so just also to help you navigate the answers, the answers of A, B, and D, the first one is pretty similar. There's a difference in C in the first thing being printed, and the second part is also a bit weird. All right, I'll switch back and forth a few times to give you a chance to go and have a look at the code, and then Yes? Huh? You can. We'll see. When it does not compile is not an option.
Yeah, that's fine.
It will compile. I can tell you about that. I'm just going to give you the answers again so you can get an idea. This, I'm sorry, yeah, some of them it's a bit difficult to get everything on one slide. I sense there's agreement. Group number 1 here in the corner has reached agreement about what it is.
I'm not cheating. I run it afterwards.
Well, you're cheating because you're next to ruler. Ruler is cheating because he's next to you.
Oh, isn't that this puzzler? Don't they like?
Ruler's default value doesn't allow recursion.
Okay. Okay. Yeah. Do you want to go back and forth a few more times, or do you think? Yes. Okay. No. No. Yes. Most other people. So this is the code. Yeah, makes sense. And then you try it twice, right? And interesting point from Luke, but it does compile, right? This will compile and will run. Yeah. Yeah. Okay. Okay. All right. Who thinks it's A? Success and then success of an exception. Who thinks it's B? Success and then failure. Who thinks it's C? Some weird thing. Who thinks it's D? Success and then another one. Okay, yeah, okay, again. You can exercise your arms. It doesn't matter. You can put your hand up twice. It's okay. So the majority got that one right. Excellent. C, very good. So maybe the puzzle is a little too easy. Thanks to Luke for giving it away. No, that's very good. No, so I mean, the interesting thing here is that it doesn't break, right? And I mean, this is really the point. Let me just show you what's going on here. So what happens if we go to the next slide? So if we run this, we'll see that it does indeed say, you know, it's the outer thing is a success, which you would imagine when you're chaining stuff, but then inside you get this weird thing. It's like it clearly gets here, and the value from the first one is this, and the second time round it thinks that. So it's not doing what you would expect it would do, which is namely, as soon as you get a failure anywhere down the line, it would break out, which is what you expect a chain of maps to do. And as Luke absolutely said, that is because you're using not flat map, but map. The problem is that map actually works, doesn't fail. What you really want here is flat map, because what flat map does is it actually tries to extract things from the first try and then go back. So yeah, this is an unfortunate double chaining of map that really doesn't do at all what you want. Ergo, be careful when you use try when you add stuff. Yes?
Well, I would argue that the fallacy here is not the map versus flat map, but it's the value to string inside of the string interpolator. If you weren't calling on the right, if you weren't calling toString there, if you were actually doing something like maybe using show to get
Oh, of course, yeah, I know.
or to just like
It would fail. If you were trying to do like legitimate stuff that requires a typed thing and not something that really works on success as well, then this would happen. So totally accurate. There is a little bit of artifice in making this work, but yeah. Yeah. You mean here? Yeah, exactly. Yeah. So now the art of creating a puzzler is being torn apart in front of my very eyes. Very good. Yes, but this one really does what you expect, right? It as soon as it hits the failure in the first one, it'll jump out, and it will actually give you what you expect. Yeah. Of course, it's returning a try. It's returning a try of a string. It's a try of a string in both cases, indeed. But that's no, okay. Let's not talk about the deep craft and art of making puzzles. Let's just move on to the next one, because this is also fun. Right. So what's happening here? I have a couple of partial functions, and so one basically has a code catches evens, and the other one catches odds, right? So that's the only case that's defined. It has a guard. So the first one only matches on even, and the second one only matches on odd. And then we take a seek that has only even numbers, and we map it using this nice construction of partial functions, which is even or else is odd. So it'll try to map evens, and if that doesn't work, it'll map odds. And then we pass it a seek that has an odd number as well. And here are your choices. I'll go back in a second. This is what you get. So you can say, don't forget, the first one was a seek that had 0 and 2. And the second one was a seek that had 0, 1, and 2. And here's what you can choose from. You can have, it goes list even, blah, 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 blah. The first one does even for everything for some reason. The second one does what you would kind of expect, maybe. The third one also processes all the elements, but doesn't return even or odd. And the last one isn't happy. So these are your options. I'll go back to the code, and we'll go back and forth a few times, and then we'll really accelerate, because otherwise we'll only manage to do 4 puzzlers, and we've got like 4 more lined up. Thanks. Yeah, no, so, yeah, you got it, Daniel, I think, but it's going to be fun. All right. So, I mean, there's no, the printer lens really, there's no like typography weirdness there. It's really is even or else is odd. And for those of you who don't know what or else does, it's a chaining of partial functions attempting to apply first one. If it doesn't apply the second one. All right, here are your options again. We might have to run over by 5 minutes, unless we all have the planes to catch like me. Do you want to see the code one more time? And I mean, the mapping is obviously just converting, you know, if it matches the partial function, then it'll take the result and put that in the resulting list in this case. Who thinks it's A? One. Who thinks it's B? Who thinks it's C? Who thinks it's D? A whole bunch. Very nice. Let's have a look. Fun, huh? So I like this puzzler a lot, but it is admittedly a little bit of a cheat. Well, it's not a little bit of a cheat. The thing is here. I obviously snuck it past some of you, not me, the person who actually pointed this out on Scala Lang. The things you are defining there is even and is odd are not partial functions. They look like partial functions, but they're not partial functions. And I'll explain why, but I'll first of all show you what it looks like to actually define a partial function. Let me show you this one again. This is what we're doing here, right? Partial function, type, then a body. Well, that's not correct. The way to define a partial function is to give it a type and then go equals. Right? This is now for everyone. So this one works the way you would expect because it really does even, odd, even. The problem is that what you're making here, and don't ask me why this works, this is a partial function has a companion object. And the companion object's constructor takes a function and returns, but the thing in the middle is a function, then it returns a function. It returns a partial function, but it's valid everywhere. Yeah. Yes. So the point is that is even is applicable everywhere. At least it thinks it is applicable everywhere. So that when it hits the 1 down here, it tries to apply is even, and it says, okay, I'm applicable, and then it tries to do something with 1, but because the actual body of the function can't handle 1, it goes bang. That is really, and I mean, so this is, yeah, that is, it's pretty nasty. And I mean, of course, yes, I would agree if you said, well, okay, this should never happen. But you notice the syntax is sufficiently close that it's, you know, if you come across this in your code, it's good to have a linter or something to look out for this, because this is clearly not something that you would intend to happen. All right, that was a kind of fun one. Oh, yeah. So this is one I like. So let me talk about this. What do we have? We have an object. This one doesn't rely on being run in the REPL, as far as I know. We have 2 overloaded methods. The first one, overload A. The 2 versions of the overloaded method, one accepts a unit and the other accepts a unit and nothing. And the second overloaded method accepts, one of the versions accepts a unit and the other accepts nothing. And then you try to call overload A with 1 value and overload B with 1 value. Here are your options. The first statement prints I accept a unit, and the second fails to compile. The first statement fails to compile, and the second prints I accept nothing. Both statements fail to compile, and both statements print I accept a unit. Here are your options again. Notice, by the way, I mean, there's no magic here. 99 is an int, right? There's, Now, I'll say up front that there is advice in the Scala community, I'm not sure to what extent I share it, but that overloading is bad and should be avoided. And we have things like the magnet pattern, which will not work anymore in Doddy from what I remember because of auto-tupling. But to try to get around this stuff, but this is a kind of interesting one. All right, here are your options again. The first statement So the one overload A. Overload A is the one that has 1 and 2 arguments. Prints I accept a unit and the second fails to compile. The other one is the first statement fails to compile and the second prints I accept nothing. Both statements fail to compile and prints I accept a unit, I accept a unit. And I mean, I'm not giving away anything here by saying failing to compile typically means unable to find an applicable method, right? There's not talking about, I don't know, overload is not a valid name for a method error. All right, we're going to run out of time, so let me move fast here. How many more? I think we have 2 more. Who thinks it's A? The first statement prints I accept the unit, the second fails to compile. Who thinks it's B? Second fail. Who thinks it's C? Both statements fail to compile. Who thinks it's D? I accept the unit, I accept the unit. Let's have a look. Let's have a look. Next slide. O overload A, O overload B. Run. So, And the way, so I'll show you another one. The way represent works, it clearly can't compile the second one. A represent doesn't allow you to run them separately, so I've commented out the second one to show you that the first one, in fact, compiles and prints I accept a unit. So the answer, my friends, is A. So what is happening here? Pretty fun. So there's a couple of really interesting things going on here, and this is all related to the overloading resolution algorithm of the Scala compiler. And in fact, from what I understand, there's a change because they added. Okay, so when the Scala compiler cannot figure out which method to call, it used to, I guess, I'm not experienced enough to know that, it used to have the long type-based algorithm to try to figure out which method is applicable. It still does. Well, that's the second phase, but what I gathered, what was added at a certain point was something called shape-based resolution, which is in the spec, and which says the following thing. Well, before you start doing expensive computations on types, first of all, find out whether the number of arguments matches. So what happens in that case, it ignores the types and it just says, well, is there one unique alternative that I can pick that has the right number of arguments? Which in the case of A is true. It looks at it and it says, okay, well, there's one unique argument. And it doesn't immediately apply yet, but there's only one method that has only one argument. And that is namely this one. Now it has a problem that it has to try to figure out how to make int become a unit. And that is not immediately obvious how that's possible, but it's possible due to a rule called widening, if I remember, type widening or something like that. There's an implicit conversion. Implicit conversion, which is applicable, but it's only applicable in the case that you have something and you want to go to unit, and then it's applicable.
Actually, it's not an implicit, it's even worse. If you
It's implicit conversion, like
you can't mask it.
No, it's not an implicit thing, it's not an object in there somewhere, it's actually somewhere in the spec there's a sex20c whatever, that is a section called implicit conversions, which is about magic that compiler can do. But there's nothing you can, so it's, Yeah, exactly. So it's things like value discarding. Sorry, this is called value discarding. And you'll see a warning from the compiler about this.
It's worth noting that, at least for the first line, that infix notation is a dead giveaway.
Yeah?
I thought so anyway. So
Oh.
you can flat out ignore the second overload because it takes.
Well, that's because of what you talked about, like shape matching.
So I'm glad to hear it. It's always good feedback. Happy. So the second, what happens in the second point is that shape-based overloading fails because it can't determine a unique method to call because there's 2 options with 1 argument each. And the point is that that means that the compiler doesn't know what the target type should be, and that means that the implicit conversion doesn't apply because the rule of value discarding only works when you know what you're looking for. And since the compiler doesn't know what it's looking for at this point, it says I can't find a unique version. And this is even though one of these options is nothing. So there's obviously no way int can ever become a nothing because, well, nothing is a nothing. So, okay, so that's a kind of interesting one.
what happens when if you have a default argument for overload A or n?
That's a good question. I'm not sure. Let's try it. I don't know. We have our person in the front, and we have our professional trier in the front here. So let's give that a try. So we'll know in approximately 2 seconds while we're thinking about the next answer. Here's one: extract or fail. So I mean, so the long story short, be aware that overloading is complicated, and that ideally, obviously, try to be aware that this shape-based resolution happens. I'd have to have a look. What was the advice we gave? Actually, I'll look it up. I don't have the time, unfortunately. It's good that I have a copy of the book at the front. Oh yeah, the book. Oh no, let's ignore that. So let's go to the next puzzler. Basically, overloading resolution. It's worth understanding overloading resolution logic because it can lead to some interesting quirks. Extract or fail. God, I'll try and go really fast because we have two we want to discuss. This is kind of interesting. So we have two vals. We have n, which is a null, and n object, which has a type ascription of object, it's also null. And then we try to do the same thing, basically, with both of them. Nothing magic. We try to match it. Is it a symbol? In which case we return it. Else we print not a symbol. Here are your options. Not a symbol, not a symbol. Both statements blow up because they're null. It prints null, not a symbol. And the first statement throws a null pointer exception, and the second prints not a symbol. Well, so yeah, no, Luke is right. I'll discuss that in a second. But the main question that you need to think about here is that should they behave the same or should they behave differently? I mean, whether we think the null pointer exception is right or wrong, would they behave the same or would they not behave the same? That's why it's called Scala Puzzlers. No, I mean, I don't know, right? It could be. You may. Yeah, you may. Compiler warnings are allowed in puzzlers. That's okay. Nobody says they have to be warning free. We don't have a lot of time, so I'm going to try and keep this pretty short because we have one more that I really want to do. What did we say about them? Okay, who thinks it's A? Not a symbol, not a symbol. Who thinks it's B? Null pointer exception. Who thinks it's C? Null, not a symbol. Who thinks it's D? Oh, two obvious answers. Let's have a look. So that was that one. We've been here. Let's run it. Yeah. So it's a null. Okay. Again, represent kill dies on the first one. So the first one is a null pointer exception indeed, and the second one, once I've commented that one out, prints not a symbol. So the answer is this one, D. And what's going on here? Well, the null pointer exception, as we already heard, is indeed a bit of a bug. But the thing is not the null pointer exception. The thing is, why do these behave differently? Surely if the second one, or the first one throws a null pointer exception, the second one should throw a null pointer exception as well. And because they don't, what we're really discovering is that they go down a different code path. And the only reason they can go down a different code path is because of this type ascription here about the object. But how does this happen? They're both the same. And here's what happens. Symbol.onApply, which indeed contains a bug because it doesn't accept null. Symbol.onApply takes an anyref. And that means NN, which is of type null, perfectly valid. So in the first case, it just goes, oh yes, matches, excellent. So it goes, tries to do symbol.onApply and it goes bang. In the second case, because it's an object, this compiler can't actually figure out whether it can pass it to symbol.onApply because of the type of unapply, and it actually inserts a instance of statement. If you look at the output of the compiler, there is an if n object instance of any ref in there before it tries to call symbol.onApply, and because null is not an instance of anything, using the instance of check, it doesn't go down that code path. It goes down the other code path, which prints not a symbol. Interesting stuff. So so in other words, the behavior, even if symbol.onApply wouldn't blow up, the first one would go null and the second would go not a symbol, which is still a bit strange. The one thing I did want to say before we do the last puzzler about this one, the advice that we were talking about was this is not a problem if you construct it like this, but the weird thing is that say O is defined in a library, and you are calling overload, assume it hasn't been overloaded yet. So assume there's only one version of overload A and overload B. And you're calling the library perfectly happily. And now I as the library writer, I had an overloaded method. And now suddenly all my client code breaks, potentially. But it's not because there is an overload resolution problem. I mean, nothing clearly can't apply at the point, just simply by adding another method of the same shape. So even if the possible argument types are totally disjoint, simply by adding another overloaded argument of the same shape, I can cause stuff to break for downstream users, which is pretty. I don't think there's much you can do about it, but be aware that having multiple overloaded arguments of the same shape, maybe default arguments or these kind of things are better. So, oh yeah, we're already late. So this I think will be the last one. Yeah. Yes? Yes, it is. No, we can do it. There's only 2 more to go. I was just trying to make as though I had like a trillion puzzles.
I have to run. It's not the last talk of the day, guys. You can ask me anything over at the big hall over there.
Okay, right. So then we lose our one of. All right. Okay. Let's have a quick look. So let's just do this one. This one is a lot of fun. The last one is long. You can look it up on the site. This one is just been added, so you probably haven't seen it yet. Think of a card. You have a case class called card, which has 2 constructor arguments, and thus 2 vals. It has a number, which is an int, and suit, which is a string, and the suit has a default value, clubs. And then you have, you calculate the value between 1 and 13, so it's 1 based. So you want to just clean up what's passed in. And then you have a method which takes an implicit list of cards, which is the deck, which is like some global configuration parameter. And you can ask a card whether they're in this global deck. So you can say, card, are you in a deck? And so on. And so then we make the deck, an implicit val deck of list card 1 spades, and then we define, because we don't always want to have to construct cards, if you just write 1, I mean since we have a default suit, that's a perfectly legitimate card. We have an implicit conversion that takes an int to a card, which does, just you give it the int and then it turns it into a card. And so then we try to print 1 is in deck. So we ask 1, are you in the deck, in the global deck? And here are your answers. This throws a runtime exception. Prints false, I'm not in the deck. Prints true, I am in the deck. Or does not compile. So who thinks it's A? Let's cut it off there. Who thinks it's A? There's a runtime exception. 1 person. Who thinks it's B? Prints false. Who thinks it's C? Prints true. Who thinks it's D? Fails to compile. Let's have a look. Last one of the day. New. There's 1 is in deck. Syntax highlighting as well. Nice, huh? Whoa, whoa, wow. Okay, so what's going on here? So the answer is, in fact, A throws a runtime exception. And there are actually quite a few puzzlers constructed around the same, and we should all, you can sign a petition. We have a Save the Puzzlers campaign, which we don't, but it's a good joke because, as we all know, war has been declared on them. And I think this legitimately is one particular class of puzzlers that really needs to go. This one is a bit more difficult. I can construct lots of interesting variants of this one, but what's happening here is the following. The trick, the magic trick, is that the implicit that is being applied to convert 1 to a card is not in fact into card, which is what you might think, but it's actually deck itself. Deck is a list, but a list is a function. So this implicit deck, whoa, and the one part that is arguable in the spec, which is certainly inconsistent in the way the compiler behaves, is that if this were not an implicit def but a def, if you were looking for a def to apply at this point, which was of a function type, you would get a ambiguous resolution error because a val and a def of the same type are not. But because one is a val, there is a preference, a sort of weird preference, and I don't know, I couldn't find in the spec where it's justified. There's a preference for implicit vals over implicit defs in apply using conversions. So what actually is happening here is that it's calling deck.apply 1 is in deck, and the deck.apply 1 tries to find 1 in the deck, and of course it's not. There's only zeroth element in the list, so there's no 1 in the list, and that's why it blows up. If I call this, if I actually construct a card, so isInDeck actually works. If I don't require that particular implicit conversion, everything is fine, and it says yes, this one is in the deck. So this all works quite nicely up here as it would be expected, but the implicit is not the one that you thought it was. That was pretty funny. I like that one. That's pretty. So let's skip this one. This is long but interesting. First of all, did we all have fun? Yeah. Yay. And the most important thing, so I mean, much as you might think I sit there and spend too much of my time trying to figure out puzzlers, which I do, this is a community effort. Scala Puzzlers is just a site. Most of the puzzlers that are there have been contributed by people who found this themselves, put them on Scala Lang. Please, if you come across something, no puzzler is too simple for us to at least consider. So put them out, put them out there, and you will have the unenviable privilege of being hunted down by the TypeSafe team somewhere in 2.16 or whatever, 2.15, and eliminated if you're very lucky, just not personally. Thank you very much.